Good morning, students. In this video, we will practice about formulas and units in physics. Let us start. So, in this slide, you can see three columns. First column, second, and third. In the first column, you can see we have quantities with their letters. Second column has their units, international units. Third column, it is formulas there if there is any formula. Now let us start. First quantity here is very easy, which is called distance. The unit of distance is meter, m. Now same distance or the unit meter is same unit for distance as well as radius, because radius is also kind of distance or length. Now we have a similar quantity which we call displacement, similar to distance, only the difference is displacement is vector quantity, distance is scalar quantity. We are not going in detail here with, about scalar and vector. Okay, so distance or radius or displacement, every one of these three quantities has the unit meter. Now next is velocity or speed. We use the letter V for this. We use radius letter, we use R also. The letter for radius we use R also. Okay, so now we were talking about velocity or speed. We have the unit meter per second, and the formula is, if it is velocity, displacement divided by time. If it is speed, distance divided by time. Now change in velocity, we call it, this letter we call delta. This is a special letter, delta V, change in velocity. Because it's still a velocity, the unit remains same as velocity unit, meter per second, meter per second. And see, the change in velocity is difference in the velocities final and initial, Vf minus Vi. F here is final, I initial. Initial, it means starting. Now next is time interval or change in time. See, whenever we talk about change, we use this letter. We call it delta. So the SI unit for the time or time interval or change in time or period is second. And the formula will be, similar to change in velocity, change in time equal final velocity, here final time, minus initial velocity, here initial time. Now next comes acceleration. Acceleration is simply denoted by A, and the unit becomes meter per second squared. You know, because the formula is A equals change in velocity over change in time. See, whenever we talk about acceleration, we talk about change in velocity. Accelerate, yeah, it means change in velocity, change in speed. Okay, so, and let me tell you one thing, that you can get the unit from the formula. For example, the formula for velocity is displacement over time. Now, what is the unit of displacement? Unit of displacement is meter, and divide by unit of time is second. So the unit of velocity will be meter divide second. We call it meter per second. So similarly, you can see here the unit of acceleration is unit of velocity, which is meter per second, divide by unit of time, which is second. So meter per second divide by second gives you meter per second squared. Let's move to the next slide. Centripetal acceleration. See, we in the last slide we saw acceleration is A. Here centripetal acceleration, A subscript c, small c at the bottom, we call it subscript. Okay, so AC, it's centripetal acceleration. Because it's acceleration only, the unit remains same, meter per second squared. Now the formula will be little different, which is AC equals V squared divided by R. I will show you V can be written as 2 pi R over T. So if we put V as 2 pi R divided by T, and we have another R here in this formula for acceleration. So the formula for centripetal acceleration is, we can write 4 pi square R divided by T square. So it depends which formula you are using. It depends on the situation, questions. Some questions you need only this formula. Other questions you may need this formula. It depends. Now next is centripetal force. See, whenever we talk about centripetal, we talk about center, we talk about a circle, circular path. Now, centripetal force. We know about Newton's second law, F equals m times A. Here, because we talk about centripetal, we will use the letter C, small letter at the bottom. Now, we know that it's a force, so the unit will be Newton, N, big N. Now, centripetal acceleration, minor change, only we are using C at the bottom for acceleration, and for force also we use C. So the formula becomes, Fc equal m times AC equal, we replace AC by V squared R. See, so m times V squared divided by R. So again, we have here two formulas for centripetal force. This is one and this is second. Now Kepler's third law. Kepler's third law is about time period or period of the planets and the distance between the planet and the sun. So whenever we talk about Kepler's third law, we talk about at least two planets, planet A and planet B. So the formula is, the ratio of the periods. Planet planet A, if period is TA, then planet B has a period TB. We divide here, see, and then we take a square. That is equal to the distance of the planet A from the sun divided by the distance of planet B from the sun cube. We divide first and then we take cube. This is all about Kepler's third law. Okay. Now, in this picture, I have tried to simplify the situation. This dark black circle is the sun. This small blue circle is the planet A. And this white circle is planet B. You can see in this picture, RA is the distance from the planet A to the sun. RB is the distance from planet B to the sun. Let's move. Now, next quantity is the work. The SI unit is joule, and the formula is F times D times cos theta. What is F? Force, D distance or displacement, and cos theta. So, the theta is the angle between force and displacement. Imagine if the angle between the force and displacement is 0 degree. So cos 0 degree will give you 1. So this formula will become F times D only. Let me write for you quickly. So the formula will become F times D. And because we have a case which when the theta is 0 degree, so cos 0 degree will give you 1. So F times D times 1 will give you F times D. So this will be a special formula. It is used in some situations, some questions. Now next is Newton's law of gravitation. We have for this law has actually force formula. Force between the two bodies, between the two objects, equal G times m1 times m2 divided by d square. See, G is a number, constant, 6.67 times 10 to the power minus 11. And m1 is the mass of the first object. M2 is the mass of the second object. D is the distance between the two objects. Next is angular displacement. See, if you say angular displacement as angle, that is also correct. Angular displacement is a kind of angle only, like 30 degree, 40 degree, 50 degree. That is called, this letter is theta. And the SI unit is radian. And the other unit is degree also. Okay. So it's very important that the international unit of angle is not degree but the radian. And here is a relation between the two. 1 radian equals 57 degree. If you have in a question 5 degree, so just multiply 5 times 57 degree. If the question asks you find the angle in degree, then you need to multiply the radians times 57 degree. Some questions you need to do it in international unit. So for that, you need to multiply by 0.017 and then you will get the radian. For example, 30 degree, how much radian, how many radians? So 30 times 0.017 radian. Next is angular velocity. See, now angular velocity, it is velocity but in a circular motion, in a rotational motion. And the letter is omega. We call it omega. Similar to W, looks like W, and the unit is radian per second. Because the formula is similar to the velocity, normal velocity, here final displacement, final angular displacement theta f minus initial angular displacement theta I over tf minus ti equals delta theta over delta t. Similarly, angular acceleration. See, we have a cousin here. Linear velocity, angular velocity. Normal acceleration, angular acceleration. Normal force, now angular force, which we call torque. Okay. So angular acceleration, the letter is alpha. Looks like small a. We call it alpha. Radian divided by second square. The formula will be alpha equals final angular displacement minus initial angular displacement divided by time interval. Here is a relationship between linear velocity which is normal velocity, and angular velocity. This is the relationship V equals R times omega. This triangle will help you. For example, if you need to find V, you multiply R with omega. If you need find R, you divide V by omega. If you need to find omega, divide V by R. See, R is the radius of that circle actually. Okay, I can make quickly here. Like, see, this is a circle, for example. This is the radius of the circle, and there is velocity, the linear velocity, which is along the tangent of the circle, and the direction of omega, angular velocity, is at the perpendicular direction of this r and velocity. Okay. So next is torque. Torque is, think it as a force in a circular motion. Torque, the formula for torque is, this letter is called tau, tau, which we use for torque. Torque equals F times R times sine theta. Theta is the angle between F and R. Now, next is net torque. See, if there are two torques acting on a system, and if the two torques are equal and opposite, we can write this. Torque 1 minus torque 2 equals 0. And we can use this formula to find, the unknown. See, torque can be F equals R also. If sine theta becomes 1, if sine theta becomes 1, we can have the torque as F times R times 1, which is F times R only. So this case is when theta is 90 degree. When theta becomes 90 degree, then the torque equal F times R, because sine 90 degree is 1. Speed in circular motion. Speed in circular motion, again, because this is a speed, the letter will be same, V, unit will be same, meter per second, and because this we are considering a circle here, so the total distance equals 2 pi r of a circle, the circumference, and divided by time period. So the formula is 2 pi r divided by t. Next formula is speed of satellite, which is meter per second. Unit is meter per second because this is again speed. Speed. Formula will be different. We have modified. We have got this result. V equals G times M small e divided by R, where G is, remember, same constant, which is 6.67 times 10 to the power minus 11. M is ME is E stands here for the Earth, because here we are talking about satellite of the Earth only. That's why we are using the mass of the Earth divided by R. R is the total distance between the center of the Earth and the high satellite. See, if it is for Jupiter or other planet, we will take here mass of the Jupiter or mass of that planet. Now, next is period of satellite. See, whenever we talk about period, it means time here. So, period of satellites, you can see the letter T for time and the unit second. The formula will be T equals 2 times pi square root R cube divided by GME. And just we introduced before, this letter or this sign is called delta, and this means change. Thank you very much for watching the video.